Hello everyone. In this video I'm going to go over differences between adding and subtracting rational expressions and between that and solving. I've noticed there have been a lot of questions on and confusion about when we do which, and I'll try to clear it up and re-explain it in this video. When we add and subtract a rational expression, for example, if I said x over 3 plus x plus 1 over x minus 4. Notice the question here, there's no equal sign, and there's the instructions for this would read either simplify or add and subtract. So again, because we see no equal sign, the question is reading simplify. We're going to say, let's find the least common denominator. So our least common denominator in this case would be the combination of our 3 and x minus 4. So we'll say 3 times x minus 4. Now, you'll see this in a second. This is very similar to when we solve rational equations. Again, the difference is, because there's no equal sign, our goal here is to get the same denominator for each of these terms. Whereas with solving equations, our goal is to get rid of the denominator. So here, my LCD, I want to say, what can I multiply each denominator by so that I get the least common denominator? My first one, I3, it's missing the x minus 4, so I'll multiply that to the numerator and denominator. Hopefully you can read that. My second denominator is missing the 3, so I'll multiply numerator and denominator by 3. Now we know what our denominator is going to be when we add and or subtract rational expressions. Our denominator is going to be the least common denominator. So what I like to do is I'm going to focus on just the numerators for now. Save me some work. Now I'm going to evaluate this expression. I'll combine my like terms. First of all, I'll distribute. Combine my like terms, now have x squared minus x plus 3 over my least common denominator. The last thing we want to do is see, can we factor my numerator at all? In other words, is there a number that can multiply to 3, since this is a trinomial? Is there a number that can multiply to 3 and combine to get a negative 1? Are the two factors, and there's not. 3 and 1 is the only factor we have, and there's no way that 3 and 1 can add or subtract to get a 1 or a negative 1. So we're done. And again, when we add and subtract, our goal, you can see our final result is a rational expression with the denominator of the LCD. Now let's look at one where we're solving. Let's say x over 3 and, trying to get the same one, plus x plus 1 over x minus 4 equals, and let's say 2, for example. And in fact, what I'm going to do is, I'm going to say, I'm not going to do that. Let's do, because I want to make sure this works cleanly. I'm actually going to say equals an x. And let's see, let's make sure that I'm going to make sure we don't get into quadratic equation territory. And let's see, that would be and I'm going to make one adjustment here, just to make sure we have a nice clean answer. Let's say x over 3. So again, I want to find my least common denominator, which in this case, hopefully that's a D, is going to be the same. Now what I want to do is the difference here again. When I solve rational equations, my goal was to get rid of the denominators, as opposed to back here, when my goal was to get the same denominator on both expressions. So I'm going to take my least common denominator, and I'm going to multiply it now to every term. So again, that's the difference. When we're solving and we have an equation, we're trying to get rid of our denominator. So once we find the LCD, this is when we multiply to each term. And specifically to the numerators. And the idea being now we're going to cancel out with our denominator. So in here, these two 3's cancel out. Now if you wanted to, you can multiply the x times the 3 and distribute the x to the x and the minus 4. But it would just be tedious and it wouldn't be necessary. The whole point of this is, since this is all multiplication up here, everything would cancel out, in this case the 3. So I'm left with x times x minus 4. Here my x minus 4's would cancel. Plus 3 times x plus 1. Here the 3's would cancel, and I'll have, and let me move this out of the way. I'd have x times x minus 4. And again, notice there's no denominators. That's our whole goal with solving rationals. So the same thing, I'll distribute. And now I want to continue to combine like terms. So let me combine my x squareds. I'll move the one on the right by subtracting it, since it's positive. And what's nice is they cancel out. Now I have negative. I'll combine my negative 4x and 3x to make myself negative x plus 3 equals a negative 4x. Now I'll continue to combine like terms. So let's see, I'll move my 4x over when I get all my variables on the same side. So I'll say add 4x. And now I have a positive 3x plus 3 equals 0. And then we go to my next page. So again, I have 3x plus 3 equals 0. And now I'm going to solve. So I'll solve for x. I'll subtract 3. So now I have 3x equals a negative 3. And lastly, solve. I want to divide by 3. And we'll say x equals negative 1. So again, this is the difference between solving rational equations and simplifying, or adding or subtracting them in particular. When we add and subtract, let me go back here, we want to get the same denominator in both of our terms, and notice there's no equal sign. When we solve, there's an equal sign, and I should put up here, you'll see the instruction typically of solve, or solve the equation. And when we see that equation and that instruction, that's when we want to still find the same LCD, but multiply each term by it. Because our whole goal, you can see down here, is to cancel the fractions out. We don't want them anymore. And no one really likes them anyway. And then we combine like terms and keep simplifying until we can solve by factoring or by here to solving the algebraic equation. Hopefully this is a good breakdown of the differences between these two processes.